Happy Wednesday. So this is the last topic that we have in preparation for your test on Friday of this week. So today we're going to infinity and beyond. We're buzzing Woody today. Okay? Right? So we're going to talk infinite geometric sequences and series. So first off, we've got to talk about what these look like. And these are going to look like it's going to have some kind of a, if it's given to you in sequence form, so then we would have something like, let's say, 1/2, 1, 2, 4, ... And these dots right here, that's the key. Okay? That's telling you that that geometric series, because we're going, or that geometric sequence, excuse me, multiplying by 2 there, is going to continue on forever and ever and ever. Okay? Another way that it might say in the wordage of the problem, it might say, oops, I spelled that wrong. Bad spelling, Lens. We'll say the word infinite somewhere. That means you're talking about an infinite series, okay, or an infinite sequence. And the last place that you're going to find this is in our old pal sigma notation, and you're going to see the infinity symbol up there at the end. Okay? So those are the 3 ways that you know that we're talking about an infinite geometric sequence or an infinite geometric series. Okay? Now, not all infinite series have sums. Okay? So there are certain R values that have infinite sums, or that when infinite sums exist. And those R values are if the absolute value of R is less than 1. That's the only time that sums exist. Okay? If it's not, if R is bigger than that, no sum exists. Okay? So if you are dealing with an R value of less than 1, then the formula for the sum is, it's on your yellow sheet for this week. Side note, if you haven't picked up your yellow sheet yet, up at the front of the room in the normal spot. The sum for the infinite, and this is only for infinite geometric. So the sum then is the first term divided by 1 minus R. That's it. That's an easy one. Okay? But again, R, the absolute value of R, has to be less than 1. If you have an R value of 2, like that first example that I gave you, we couldn't find that sum because the terms are going to get bigger and bigger and bigger. We need our terms to get closer and closer and closer and closer to 0, the farther along we go on our term numbers. Okay? So let's put this to work. Okay? So first off, I know that this is an infinite because it's going to infinity. I know that this is an infinite geometric because I've got a term with an exponent in it, okay? Or my variable is in the exponent, I should say. Okay? So this is an infinite geometric sum. So the first thing that I should do is I should check or find my R value. And if R is, the absolute value of R is less than 1, then we're good to go. Now again, from regular geometric sums, the R value here in this case is the term in sigma notation that has the exponent on it, the base, so the R value is 1/4. Now 1/4 is less than 1, so we're good there. So now I can find the sum. So my first term, G sub 1, I'm going to take 1 and I'm going to plug it into my equation, my rule, if you will. 1 minus 1 is 0. 1/4 to the 0 power is 1 times 3 is 3. So my first term is 3. Okay. My first term is 3. I know my R value. I can go right to my sum. So the sum, I don't need a term number because it's an infinite amount of terms, is going to be my first term, 3, all over 1 minus my R value is 1/4. Well, 3 is 3. 1 minus 1/4 is 3/4. Keep, change, flip tells me that that's going to be 3 over 1. That's my top. I keep it. I change from division to multiplication. And I flip my bottom one 4/3. 3 cancels out the 3, leaving me with the sum is 4. So if you take out all of the terms in this geometric sequence, the first term is 3. The rest of all of the terms out to infinity only adds up to be 1 more than that. So the total is 4. Okay? Good times. Find the sum if it exists. Well, it's an infinite because we have an infinity symbol up there. My R value, first thing I need to check, my R value is here. The absolute value of R is less than 1. So my R value is negative 1/2. Good to go so far. My first term, then, 1 minus 1 is 0. 1 minus 1 is 0. Negative 1/2 to the 0 power is 1. Times 1 is 1. So the sum is going to be 1 divided by 1 minus negative 1/2. That's my R value. 1 is 1. 1 minus a negative 1/2 is like 1 plus 1/2, which is 3/2. Keep, change, flip. 1 over 1. Change to multiplication. Flip it to 2/3. So the sum of this infinite geometric sequence is 2/3. Which is smaller than the first term. And that's okay because every other term is going to be a negative. So 1 was the first term. The second term would be negative 1/2. The third term would be positive 1/4, and so on and so forth. So that's why the sum is actually less than the first term. On this one, find the sum if it exists. Well, first thing we need to do is we know it's infinite because of the 3 dots here at the end. So that means I'm going to be following my infinite geometric series. So I need to check my R. To find R, remember, that's any term divided by the term right before it. So I get an R value of 3/2. Or I could have done 9/4 divided by 3/2. And that would have been 9/4 times 2/3, which would have been 3/2. So my R value is 3/2. The downfall with 3/2 is that it is bigger than 1. 3/2 is 1.5, and that is bigger than 1. So therefore, because of this, right here, no sum exists. Because the terms are getting larger and larger and larger, not smaller and smaller and smaller. And that's all you have to do for those problems. Once you establish your R value, if it is not less than 1, can't do it. No sum exists. Move on. Then lastly, we have this style of a word problem. A golf ball is dropped from a height of 9 feet. So it starts up, the golf ball gets dropped, and it falls 9 feet. Then what's going to happen is it's going to rebound. It's going to rebound to 75% of the height. So it's going to bounce back up, and it's going to bounce up to 9 times 0.75. It's going to bounce back up to 6.75 feet. Then it's going to fall down that 6.75 feet. Then it's going to bounce back up .0625, which is 6.75 times 0.75. And so on and so forth. And that pattern is going to continue. Okay? So we're asking for the total distance. That's why we have to get the total distance here is going to be the downs plus the ups. Okay? And so it's always going to end. Or, that makes one complete cycle. So because we're always talking about one complete cycle, and the fact that this ball, if this were in a vacuum, it would keep bouncing forever and ever and ever, we can go with the fact that the sum of the distance it took here on bounce number 1 was 15.75 feet. I took these two and I added them together. The total that the ball traveled on bounce number 2 was 11.8125 feet, which was these two numbers added together. Now, the nice part about this is that if you took 15.75 and you multiplied it by 0.75, the rate that's going on here, you would get 11.8125. So your R value here is going to be 0.75. Now that is less than 1, because as you bounce the ball doesn't bounce higher and higher and higher and higher without any added extra stuff into it. And you know your first term, the total distance that it traveled, the first term would be 15.75. So if this ball bounces forever and ever and ever and ever, that's going to be an infinite geometric sum that's going to be 15.75 first term divided by 1 minus 0.75, because that's the R value that you got from there in the problem. So that's going to be 15.75 divided by 0.25. And when you divide that gives you the total distance that the ball traveled, and the total distance that the ball traveled was 63 feet. Now, you could have done this problem in one of many ways. We did it this way, and that's fine. You could have added up all the downs, and so the downs would have been 9, 6.75, dot, dot, dot. You would have had to find the sum there. Then you would have had to have done the ups, and that would have been 6.75, 5.0625, and you would have had to done those. And then you would have had to add those two together. Either way, you get that one. Okay? Good times. Now, a couple of last little reminders here. First off, worksheet 27, the yellow worksheet. If you haven't picked it up yet, make sure you pause the video right now, walk up to the front, pick it up. Okay? The answers to that are at the bottom of that worksheet. Okay? That worksheet is due this Friday, the 17th of March. Friday is also your summative test. That is this week, Friday. Any and all missing work or any fixes to any formative, any homeworks, etc. All of that is due this week, Friday, because that's the end of the quarter. Okay? So that puts us at about a mod into Wednesday's class. That gives you 2 mods today to finish the yellow worksheet. And then I'll have another video for you tomorrow with just some problems from this unit and figuring out, or just so that you see more problems and what we're doing and how we work them. Okay? Have yourselves a great day. Hopefully your sub has also been passing out some worksheets and things that I have that I've got corrected and integrated with them. Okay? Have a good day.